All right, it's about 11. I'm going to go ahead and get started. And all right, so there's more stuff on the Canvas site now than there was yesterday. It's not finished yet, but it's almost there. All right, it's about 11. Oh, and I need to mute my, all right, so there's more stuff on the Canvas site now than there was yesterday. It's not finished yet, but it's almost there. Perfect. You get to hear that twice. And now I know for sure that I am actually sending this to YouTube, so there will be a recording of it and it'll be automatically posted at the end of the lecture when I click done. There is a recording of yesterday's lecture. I have watched parts of it. It's there. There's good audio. It's not bad. I tried to post it to YouTube this morning so that you guys could all watch it. And apparently Zoom doesn't save the file in a format that YouTube will accept. So now I have to open it in video editing software and render it before I can post it to YouTube. So sometime later today, you'll get yesterday's lecture will be posted. But we did talk about some assignments, and I think I've covered everything that I want to have us do here on this list, and it's on Canvas also already. But we have we have the 3 lectures from this week. So we're going to talk about stuff yesterday, today, and tomorrow. I want you all to go to mfelabs.org, become a basic user of the shops. And so that's on Canvas. There's instructions for how to do that. But I want you to go through the steps to become a basic user. If you did this last year, you need to do it again this year because everybody has to refresh every year. So even if you did it but it'll be really easy because there's only like 4 quiz questions that changed between last year and this year. And we think we got rid of the 4 worst quiz questions. So we think it's better. And there's some stuff in there talking about social distancing and COVID and all that now that we had to update. So go to mfelabs.org, become a basic user. Read the safety section of the CNC Quick Guide for Haas Mills. You could also read the safety section of the CNC Quick Guide for Haas Lathes. It's the same pages between those 2 books, so it doesn't matter. We're going to do chapter 1 and chapter 2 of getting started with CAM. There's a link to that in the Canvas site also. There is an exercise in there, and it's an exercise using the CAM software Esprit. I will get you information about how to install it and get a license for it to put it on your computer. But honestly, you can go through that. It's in chapter 1 that there's a small exercise. You could go through the stuff and watch the videos and not open Esprit and probably get the same benefit from it. But I think it's a little bit better if you actually can open up Esprit. And so before we move on, I'm going to talk to you about how you can get it in the app where you can run it in a web browser. And we're actually going to do it live on Zoom to prove that it works. Well, okay, it'll prove that it works for me on this computer right here. I don't know if it'll actually prove anything else. We're going to do that, and let's see. And I asked you to make a video, post it in a discussion forum. That's up there. I want to go through part of the hesitation having the syllabus posted already was trying to figure out, because we got some people that are learning remote, we've got some people that are on campus, and we've got a possibility that some of the people that are on campus are going to end up quarantined before the term's over, right? So I want to make sure that whatever I do for grading can apply evenly across all those groups of people. And which means I can't just use the normal grading scheme that I've used every other term, but I think I've got it figured out. We are going to have a comprehensive final exam. It's going to be at the end of the term. There will be quizzes on Sundays. You don't have to do them on Sunday, but they're going to be due on Sunday at midnight before the next week starts. I hesitate about having assignments due during the weekend or at the end of the weekend, because when I was a student, has anybody ever procrastinated?
I have been known to do that once.
Yeah. And I think it is a natural tendency for a lot of us. And so when and all tasks will expand to take all of the time available to complete them. And so when I have something that was due on a Sunday, I would tend to wait until Sunday to work on it. And then, while my roommates were all doing something fun because they had done all their homework already, I was still doing homework. And so since I used to do that, I hesitate to give those assignments, but people have talked me into it. So you don't have to wait till Sunday. You can do it sooner. But quizzes on Sundays. There will be other assignments. That's going to be things like doing the discussion forum. I've got some other things that instead of answering quiz questions, it's easier if you basically write an essay or do something like that. And so there's going to be some other assignments, and those are going to be determined. Some of them you'll have a couple days to work on. Some of them you might have a couple weeks to work on. Other assignments, CAM assignments. CAM assignments are going to be due on Fridays. There is no CAM assignment due this week. So there's no CAM assignment due this Friday, but in general, they're going to be due on Fridays. And then the lab practical exam is going to be at the end of the term for people who are here. There's an online component of that lab practical exam, and then there's an at the machine component of that lab practical exam. Everybody will do the online component. The people that are here will do the at the machine part of that, and then we'll weight the grades accordingly. So, but I think that keeps the grading scheme even for everybody.
Is there a quiz this Sunday?
There is a quiz this Sunday. It'll be live later today, and we can go through it tomorrow during the lecture to make sure there's no questions, no ambiguities in the quiz. And that quiz we'll have questions based on the 3 lectures from this week. Things you learned while becoming a basic user, things you learned while looking at the safety section of the CNC Quick Guide, and things that you've learned in chapters 1 and 2, getting started with CAM. There will be overlap between the lecture stuff and the things you're going to learn in this reading, so don't worry about it. And we used a pretty big font when we put this book together. So although it is like 32 pages, there's not very many words on each page. And there is a YouTube video on each page. So you shouldn't skip the videos. You should read the words and watch the video. That's the way it's intended to be used. All right, so I wanted to talk about assignments. I've done that. Let me just quickly open up Canvas. Hey, Doug. It was Doug, right? It was supposed to make sure I was showing the right thing on the screen. No. It's going to be somebody's job now. Whose job is it? It is Eli. Your job. Was it your job yesterday?
No, it was Doug's job yesterday.
Okay, it was Doug yesterday. Okay, good. Eli, your job is to make sure that I'm showing the right thing. So when I say, let's look at Canvas, you say, switch the screen sharing on.
Switch the screen sharing on.
All right, sweet. Screen 1. Share. And eventually I'll put a fancy picture so you'll know it's there. All right, so you've got my pretty face there telling you that, yes, we will have a lecture today. I did check. All the other terms have 3 class sessions for ME1800. Just this term they screwed up. But all right, so we're going to use this same Zoom link for all of the Zooms for ME1800 lectures. When we're doing lab stuff, if we do an impromptu Zoom, we'll probably do a different Zoom link, or we'll just create one at that moment for those. What did I want to show you? Oh, discussion forum.
Wait, quick question. For classes on Wednesday, is this just going to be the time that it is?
Unless too many people complain.
Okay.
And even if, I guess I get to judge what's too many. I suppose one person complaining loudly enough would be too many people complaining. But yeah, because they'll all be recorded. I could do it at 8 o'clock in the morning, but I'd rather spend some time thinking about it before we do it. And if I do it at 8 o'clock in the morning, that means I have to get up at 4 o'clock in the morning so that I can do the stuff I do in the morning and still have the time I want to do spend thinking about the lecture before it starts. And what do you guys do to get ready for class? Before you go to a class, what do you do? Somebody shout out.
As long as there's
Wake
caffeine
up.
involved.
So wake up. Somebody needed caffeine. See if anybody.
I do. I take coffee before classes.
You hate coffee before classes?
No, I take a lot of coffee
Oh.
before classes.
A lot of coffee before classes. Has anybody ever fallen asleep in class? You do the. And with Zoom, you could actually turn your video off and put your head on a pillow, right? But it's hard to do in the classroom. It was, I was in a microeconomics class. I think it was micro, it might have been macro. I don't know. It was one of those economics classes. For those of you that have spent some time on campus, it was in that giant lecture hall in Atwater, Kent, the one that's like 2 stories tall, 3 stories tall. So I was in there right in the middle of one of the rows, in the middle of the classroom, fell asleep. Woke up in the middle of some double E class. All my classmates walked out around me and didn't wake me up. And then the double E kids all walked in and sat down around me without waking me up. I don't think that was right. I think you owe it to your classmates to wake them up if they fall asleep. But all right, so if we go to assignments, right now you just see the discussion forum 1, but if you go to there, it says make a video no longer than 90 seconds, tell me why, or tell us why you decided to take this class and specify what you intend to learn. Click reply and you should be able to upload your video here. There's a way to upload a video here. You guys will figure it out. All right. We get assignments. Using is free. Okay, that's the other thing I want to talk about.
What's the due date of that? Sorry.
Friday.
Friday.
I mean,
will you
I
post?
recommend doing it this way. Hi, my name is Toby, and I took ME1800 because I really like learning, and so what I wanted to learn specifically was how to be a better person and how to make sure that my finances are balanced. I mean, you may pick a different reason, but that's what I would do.
You know what I'm saying?
Will you post links and materials for accessing those resources you mentioned earlier?
Yeah, they're there
the
right now.
Cam software and just all
yeah.
that other stuff. Will that come in the
If you
syllabus?
if you go to announcements and go to ME1800 this week,
Oh, fantastic! Thank you.
it's all right there.
All right.
And I'll make this show up on the homepage also, so it's not
All right,
just
thank
the
you.
announcements. I think it does show at the top of the homepage, maybe the announcements, but yeah. So this will be the link for all the Zooms. Yesterday was what is manufacturing. Today we're doing Buzzwords, technobabble, and lean. Tomorrow we're going to talk about prototype machining and process variables. Most of this chapter 2 here is about the same stuff we're going to talk about tomorrow. And yeah, and so I mean, the safety section in CNC Quick Guide is as easy as click on the link, read. You go like let's see, table of contents, safety, and read these 2 pages. So. All right. And I was trying to go back to Canvas. The little the zoom control pops down when I try to move the mouse to the tab I want to click on. There we go. All right, so this stuff is all here. And again, this quiz will be live later today, and we'll talk about it tomorrow during class to make sure that there's nothing, to make sure that I didn't do any stupid things when I created the quiz. You guys, if you want to go through and actually use Esprit when you do the chapters 1 and 2 part here, then you can use this software called Nutanix, and I'll put this link in that document also. but you want to go to frame.nutanix.com, Worcester Polytechnic Institute. Let's see if this works. I did it once before, but it was on a different computer. All right, it goes here. The instructions say to sign in with your WPI login, which you would have guessed because that was one of the options. Well, that was pretty slick. I think that happened because I'm already signed into this computer. Oh no, maybe I have to do this. I have to click on desktop. That's what I have to do. Now it's powering on. This can take a while. It can spin like that for a while before it starts up. Eventually it's gonna start up. While we're waiting for that, let's see what else we're gonna do. We did this. Cross stuff off my list. We did this, we're doing this, we talked about that. We talked about this, talked about this. All right, this is the last thing we do before we actually start the lecture. And it's still powering on. I feel like it should play music if it's gonna dance this long. While we wait for that, I'm going to start talking about today's topic. And when it comes back, we'll switch over to it. But so no matter what your job is, no matter what industry you work in, no matter, I mean, even here at WPI, wherever you are, there's a way people talk that's very specific to that place, to that thing. So, for example, here at WPI, we love our TLAs. What's a TLA?
Aren't they PLAs?
Oh, we have PLAs too, but what's a TLA? Tango Lima Alpha. Anybody? It's a 3-letter abbreviation. So WPI, we have WPI, PLA. We have, what else do we have that's 3 letters at WPI? Oh, well, we have CAD, we have CAM, we have, oh, hey, the thing's opening up. Establishing connection, it's almost there. Switch back to the screen share. If I can find the controls. All right, so eventually you get, it'll say establishing connection, it'll come to this screen. You're gonna wanna use Esprit, double click on it. There are a couple different ways to get files in and out of this. You will get this message when you try to start Esprit, click OK. It will open up this security manager. Find one of these licenses down here that doesn't have this little symbol next to it and click on it and close the window. And the software will start. You're gonna have to click OK. This is pretty cool because it'll actually run Esprit and SolidWorks at the same time. It's doing all the processing on a server somewhere, and all you need to run it is a web browser. I have not yet tried to run it in a web browser on my phone, but I bet you it'll work. And I bet you before the term's over, somebody will tell me that it works. All right, eventually Esprit opens up. No way it's taking so long. Oh, I see the little thing. It's coming, it's coming, it's coming. Here we go. All right, so you'll be able to do all the commands as soon as it's done opening. Get rid of these extra toolbars. And so you'll be able to get familiar with the interface here before we actually start doing assignments next week. I mean, one of the steps in the chapter says to go to the help and to look some stuff up and read about it in the help. I actually think the help in Esprit, especially the context sensitive help, is amazing. And using it will help you learn how to use the software much quicker. All right, so that's about getting into a spree. The other thing you need to know about this Nutanix thing, just go ahead and close this, is getting files in and out of it. There is a little icon down here somewhere about uploading files. There you go, upload files. You can click that. You can drag and drop files in. That works, and there's a download feature in there. You can download them back to your computer. They don't stay on the desktop here. So if you close the desktop and come back in, anything you previously uploaded is gone. The other way you can do it is you can go to the file manager here, and you can connect it to your OneDrive account. And you have to log in, do that stuff. But you can connect that directly to your OneDrive account. And then those files live in the cloud. They're not directly on this desktop, and you can edit them from there. We have found that, especially if it's a large, complicated file in a spree, if you close out of a spree and save it, or if you save it but don't close out of a spree, it doesn't necessarily sync with OneDrive, and you may lose the most recent changes. So just make sure that you check those things out, but it shouldn't be a problem. And then again, you'll also be able to install a spree on your own computers. So now we've talked about how you can do the assignment for this week. That stuff is done. This stuff is done. Get a real eraser. All right, we talked about all this stuff. And that only took 20 minutes. Now we're actually ready to start class. Stop the screen share. Okay. So no matter where you are, there are things that you say that people in your industry know about. Has anybody ever been on a boat? What does
Yes.
What's starboard mean on a boat? You go just
Right.
say it. The starboard is the right side of the boat. Port is the left side of the boat. Forward or the bow is the front of the boat. Aft is towards the back of the boat. Right? Well, there's always these terms. You can't use the bathroom on a boat. You have to go to the head. You can't cook in the kitchen on a boat. You have to cook in the galley, right? So all industries, we have these words that you need to use. And now most of you probably won't end up having a career where you're working directly in a machine shop all day long. But you probably will end up having a career where you probably will. I don't know. A lot of you probably will have a chance to, in your career, interact with people in the machine shop, especially right after you graduate from college and you get hired at some engineering company. Maybe you get hired as a design engineer and you're making prototypes for the next version of the thing that they're going to be selling. And your boss says, so draw this thing up, bring it down to the machine shop and get them to make us a couple so we can play with them, make sure they work. That's kind of a common thing. I think a lot of you aspire to go do a job like that. If you go into the machine shop, you will encounter what we refer to as the cranky old machinist. And has anybody met the cranky old machinist? Anybody? Anybody ever had to interact with the cranky old machinist? I can tell you for sure that even if the machinist you're interacting with is an 18-year-old woman, she's a cranky old machinist when she's interacting with you. Their favorite thing to do is to make you exactly what you asked for, especially when they know it won't work. And if you go in there and you act like the hotshot engineer and you tell them, no, this is what we got to have, that's what they're going to do. But if you know some of the words, you don't have to know all the words, But if you know some of the words and you speak the language just a little bit when you talk to them, and if you ask them for their advice, even if you're not going to take it, it's nice to ask them. They will help you, and they will make sure that what they make actually solves your problem, isn't just the thing that you wanted. And so as we go through the class, there's going to be some of these words that you're going to pick up. There's examples. Let's see. Does anybody know what a thou is? Go ahead.
A thousandth of an inch.
A thou is 1,000th of an inch. Anybody know what a tenth is? Anybody else? Go ahead.
10,000ths of an inch.
A tenth is 10,000ths of an inch. And so if you go in and talk to the machinist and you think a tenth is 0.1 inches, they're going to know you don't know anything. Oh, what are some other good ones? Oh, well, there's the micron. The micron is especially complex because there are two different microns that we talk about. There's the micron that's 1,000,000th of an inch. And then there's the micron that's 1,000 nanometers. Not the same length. What else? Another good buzzword. Anybody else got any good buzzwords that they know about? Or these are not really buzzwords. This is more jargon. Well, we got CAD. What's CAD? Go ahead, just shout it out if you know the answer. What's CAD?
It's just computer-aided design.
Computer-aided design. What's CAM?
Computer-aided manufacturing.
Or machining, people debate that. What's CAD, CAM? What's process variable? Anybody know what a process variable is? Besides the focus of tomorrow's lecture? Process variables. All right, well, let's think about what it should be. What's the process in manufacturing? What are processes in manufacturing? Anybody? Just go ahead, unmute and speak if you know what it is. So are the processes in manufacturing, are those the things that we do to the raw material? So our goal in manufacturing is to take raw material, turn it into a product. The processes are the things that we do to the raw material. What's a variable?
Just the multiple ways you can perform them, I guess.
So a variable are the things that we can change, right? So a process variable then are things about the process that we get to control and adjust. So if we get like dependent and independent variables when we do math, right? It's the same thing. These are the independent variables. These are the things that we get to change that impact the performance of the process. So PVs. So we understand process variables. All right, so if process variables are things we get to change, what are the design parameters?
Anybody? Like the specifications that whatever you're making.
The design parameters are specifications, right? They're the things that the designer gets to change, but we as the manufacturer, we don't get to impact the design parameters. The designer chooses those. They tell us what they are. We manufacture the things. All right, so we got process variables, design parameters. We've got all kinds of terminology about measurement. And oh, so here's some process variables. We got feed. We got speed. We got depth of cut. So those are going to be process variables that we're going to spend a lot of time talking about in this class. What do you think the feed might be? And it's not the stuff you give to the cranky. It's not like the donuts and the coffee you give to the cranky old machinist as a gift when you go into the lab. It's not that.
It's how fast you move the cutting tool.
Yeah. So if we're doing, and so in the class we're going to be doing milling and turning. You do milling in a milling machine. You do turning. Well, I suppose you could do turning in a turning machine, but we usually call them a lathe. So when we do milling, the tool is spinning and it's got sharp cutting edges on it. The tool spins around and it moves sideways through the material and it removes material, right? So the feed is how fast is it moving sideways? Except when it's moving vertically instead of sideways. Then the feed is how fast is it moving vertically. If it's moving diagonal, you guys can figure it out, right? But it has then the speed is how fast the tool is spinning. Now feed, and we'll talk about the units of stuff for feed and speed. But the speed is how fast the tool is spinning. And so you could do that in revolutions per minute, right? RPM. So that could be how fast your tool is spinning around. And that's easy for us to measure. It's basically, what do we call that? Angular velocity, right? But what's really important is the cutting edge of the tool. And it's how fast is that cutting edge moving sideways through the material. And that is going to depend on two factors. It's going to depend on that RPM. So if the cutting edge is out here at the edge of the tool, we've got our rotation, our RPM, and we've also got the tool radius, or 2 times the tool radius. What's 2 times the tool's radius?
Diameter.
2 times the tool's radius is the diameter, exactly. And so how fast, if the tool is feeding in this direction, and we've got workpiece material here, we're feeding in that direction, we're spinning in this direction, how fast is this point moving relative to the workpiece material? Wait, let's forget about the feed. Let's just say it's not feeding, but it's about to feed. Just before it starts feeding in that direction. How fast is the cutting edge of the tool moving relative to the workpiece material? We can figure it out with math, right? Anybody want to figure out what the formula is? You could Google it, but that wouldn't be nearly as much fun as figuring it out. Any guesses? You guys are gonna have to guess.
Isn't it RPM times the radius?
It's related to RPM times the radius. We need RPM. We're gonna multiply RPM by something. So how far does that point go every time it makes a revolution?
2 pi r.
2 pi r or pi d. So if we take, then let's think about what are the units. So what are the units for RPM? They're revolutions per minute. And what are the units for circumference? Some unit of length, right? So let's call it inches. Since we usually use tools that are in the range of inch sizes. So times inches, but it's the inches per circumference. So it's actually inches per revolution, right? So the revolutions go away. We get inches per minute. All right. So this is the surface speed. Which is actually what's important to us because that's what determines how well the material is going to cut. The problem is we don't use inches per minute to describe surface speed. It's another one of these jargon technobabble things. If we say surface speed, then we always mean feet per minute. So how do we take inches per minute, make it into feet per minute? There's got to be a factor of 12, right? Right, so we either divide or multiply by 12. I never remember which one it is. I always figure it out at the moment I need to do it by canceling the units. Did you know that engineering is math? Just a bunch of word problems. Cancel the units. And now you not only had an engineering lecture today, but a poetry lecture. All right, service speed, technobabble. All right, what else? What time is it? Time we got? All right, perfect. Why do we have manufacturing companies? Just shout out the answer. Why do we have manufacturing companies?
We need things to be made.
We need things to be made, right? We do need things to be made. If nobody makes things, then we don't have any things. So I agree. What keeps a manufacturing company in business?
We need things to be made that we want to buy.
Right. So we will want to buy stuff. So what keeps the company in business is people buying their stuff, right? So them making stuff that people actually buy. All right. So at the end of the class yesterday, we talked about value. And what's value? Value is how much the customer is willing to pay for the stuff we make. So this is determined by the customer. Minus cost. And the cost is actually the cost of doing all the stuff we had to do in order to make the value for the customer. So that includes the cost of the raw materials, the cost of doing the machining, the cost of buying the tools, the cost of paying the janitor as attributed to that one part. And so value minus cost equals profit. And if we divide it both by time, it equals profit rate. And as a manufacturing company, what we would like to do is maximize our profit rate. Well, we always want to have a positive profit rate at least. We're not always good at maximizing things, and maximize isn't always the best goal, but we need a positive profit rate. How do we get it? How do we get the profit rate to go up in this equation?
Increase value, decrease cost.
So we could make value go up. We could make cost go down. That will make the profit rate go up. What else could we do?
Also decrease the time it takes.
We can make time go down. What happens when time goes to zero? Infinite profit rate, huh? We never actually get to zero, but we can approach it, right? We want to do that. So and we can all envision what goes on in manufacturing, right? How do you make the value go up?
Higher quality.
Does having a higher quality necessarily make the value go up?
Making that people will pay more for the object.
I think the only way you actually make the value go up above whatever you have already determined that it is by convincing, so sales and marketing, is convincing the customer that it's better, convincing the customer they should pay more for it. I think that's the only way you can make the value go up. Now, you add value by doing your processes, but if you want to make the value go up, you're going to focus on things like sales and marketing. How do you make the cost go down?
Laying off employees.
If you've ever followed the stock market, you'll notice when large corporations have mass layoffs, their stock price goes up the next day because they cut costs. And so on the scale of corporate enterprises, you may think that you're doing something good when you lay off a bunch of people and cut costs and your stock price goes up. On the grand scheme of actually getting value to the customer, that usually isn't an effective way. So if we want to focus on how do I make the cost of shipping this one part to a customer go down, how do you do that?
Eliminate wastes in your shipping processes.
Say again?
Eliminate wastes in the
Eliminate
shipping
waste.
processes.
So don't do things you don't need to do, which is why I question whether or not increasing the quality was going to actually increase the value, because if the customer isn't requiring that additional value, that additional quality, if the customer is not willing to pay more for it because it has that additional quality, then actually increasing the quality makes the cost go up and it's wasteful. So you want to be delivering the quality that the customer needs. And that's why I didn't automatically jump at increasing the quality to make the value go up. Now, if you increase the quality, it may be a lot easier for sales and marketing to convince the customer that it's better. So that's certainly a tool. But all right, so we want to eliminate waste. What kind of things are wasteful in manufacturing?
Wasted time in production.
So time is often wasted. So the time, what kind of times? So the time that the machine tool is actually where the tool is spinning and we're moving through the workpiece material and we're making chips and turning the raw material into the thing we want, is that time wasted? That's actually in a machining operation, that's the only value added time. But so at our machine tools, and you guys will see this next week, but our machine tools will use multiple different tools, so multiple different cutting bits to machine the parts. And so the machine itself automatically changes from one tool to the next. But the time that it spends moving the tool holder to the tool change location, operating the tool changer to put the new tool in the spindle, moving back to the workpiece to start cutting, that time is wasted. If you could put the fixture closer to the tool change location without crashing, then that will have a more efficient, it'll be a less wasteful tool path. There was an MQP group I helped advise a couple years ago, and they worked with a local manufacturing company to look at just one process that they were doing. It was one component that they manufactured. It was, they're sort of vertically integrated. So it was a part in an assembly that was in a product that they made. This one part, they have 7 machine tools running 24 hours a day, making the same part. So they're running 3 shifts, 5 days a week, making one component for their process. Between the 7 machine tools, they had 7 different cycle times. So the cycle time is how long does it take between when you put the work piece in the machine, the raw material in the machine, and you take the finished part out of the machine. So 7 machine tools, 7 different cycle times, and there was like a 40% spread between the fastest and the slowest. And so this MQP was trying to figure out why. And so partly it was because not all the fixturing was identical. Some of the machines that had to go further. The machines move up and down in X and Y. They use servo motors. Servo motors get tuned. Not all the machines were tuned the same. They didn't have the same acceleration settings. So one machine could accelerate faster than another machine. That was causing the cycle times to be different. That MQP actually analyzed that process. They analyzed a bunch of different things around the shop. They found $1 million a year worth of waste during their MQP. So that shop could cut $1 million a year in cost for basically that one component if they follow all the recommendations in the MQP. So eliminate waste. So time spent doing stuff that's not productive is wasteful. What else is wasteful in manufacturing?
Use more material than needed.
Did you say having meetings?
No, use more material than needed.
Oh yeah. So having more material than you need. Absolutely. What else is wasteful?
Overprocessing.
So somebody said overprocessing. So that's doing stuff to the components that the customer doesn't want to pay for. Is that what you meant by overprocessing?
Yeah.
Yeah. So increasing the quality when the customer doesn't want more quality. What else is wasteful in manufacturing?
Defects.
What was that again?
Defects.
Defects. So making scrap. Scrap is another technobabble word. Scrap. Scrap is just what you think it is. It's crap with an S in front. And you don't want to ship crap to the customers. What else? We said time. Motion is wasteful in manufacturing. So one of the things that we do, and so lean manufacturing, by the way, is a set of management tools and processes to evaluate manufacturing systems that is targeted at eliminating waste in the manufacturing process without decreasing the value. So the target is maintain the value, but eliminate the waste. And so motion, moving a part from one machine to another machine, can be wasteful in manufacturing. Now you may have to do it because you need the 2 different types of processes that those machines can do to make the part. So it may be a waste that you cannot entirely eliminate. But if you put the 2 machines next to each other, then you don't have to move as far when you move from this machine to that machine. So you can eliminate waste by building what we call a manufacturing cell. That's another one, cell. The manufacturing cells where you put machines together so you can make a part. Some companies, that when a part run comes in, they'll rearrange their shop to more efficiently make that part until they're done making that part, and then they'll put stuff back where it was. I was in a lean manufacturing course. There was a guy who's doing his class project in the course. He worked at a large aerospace company in Connecticut, but I don't think I'm allowed to say the name. But he worked at a very large aerospace company in Connecticut. He looked at the manufacturer of one component, and he found that from receiving the raw material at the loading dock to shipping the part off to where it gets put in an assembly, that raw material moved back and forth through their factory buildings, and it traveled 27 miles going back and forth through the factory buildings. That was not a very efficient path for that part to get through. I think it took over a month to make the component, but there was only 5 minutes of value added time. So it didn't just move around, it sat and waited for a long time too. So that's an expensive part. I guess if you're making jet engines, it's okay, you can have expensive parts. And you certainly don't want to screw up the parts when you're making jet engines. But so there's these tools. All right, so lean manufacturing is a system of tools to help you eliminate waste. We're going to talk more about this as we go through the class, but I want you to be thinking about it. We actually, my watch just told me it's time to stand up. I haven't been in a chair since 5 o'clock this morning. I don't think it knows I'm standing. We're gonna come back to these topics throughout the class. The intent today is to introduce it. As you come across a word that you're not certain what it means, look it up, ask somebody, or just guess. It's up to you. But understanding the technobabble, understanding the jargon will help you communicate, especially with that cranky old machinist, and it'll be a better experience for you as you go out. Was there anything else we had to cover today? Oh, just one other thing. As we designed this class, so what do we make in ME1800? It's a manufacturing class. What do we make?
A Stirling engine.
Yeah, so we will make, it's actually a thermoacoustic engine, and you model it using the Stirling cycle, but yeah, we can call it a Stirling engine. So we'll make one of these Stirling engines. But is that the point of ME1800? Is making Stirling engines what ME1800 is about? So our goal isn't to make Stirling engines. In fact, I used to say adamantly that I don't care if the students make a Stirling engine during the class. It turns out that you guys like it when you do make one, and you like to be able to take it home with you. So I've changed my attitude about that. I do want you to make Stirling engine during the class because I want you to be happy when you leave, and that helps. But my goal is to make an engineer. So the value I'm adding is adding knowledge to an engineer. So you guys are the raw material in this formula. And the process of doing the lectures and the labs and the homework assignments, those are all the manufacturing processes that we're applying. And our product at the end is an engineer that knows something about how to make things so that they could later design things that could be made. And so that's my goal in ME1800, is to make you a better engineer, even if you're not going to be an engineer when you grow up. And I think it is 2 minutes over time. I'm gonna have to assign somebody to make sure I don't go over the time too now. But I will see you guys tomorrow, 8 o'clock in the morning. We're gonna talk about what tomorrow? Anybody remember?
Process variables.
We're gonna talk about process variables. These are the things in manufacturing that you get to change. Thanks very much. See you tomorrow.
Professor, I have a quick question.
Yeah, go ahead.
So I still wasn't in the class yesterday. I just got registered, and I was trying to check where I can find the lecture, for the recorded lecture for yesterday.
Yeah, yeah, there was a snafu in the lecture recording, so I have a copy of it, but it's not in a format that I can post. I have to load it into some video processing software, render it, save it back out again, and then it'll be posted later today.
Okay, thank you.